Monday, December 5, 2022, was an important day in science. The undersecretary gave this statement to the National Nuclear Security Administration, Hruby, at a press conference on December 13. This duality of advancing the research, building the complex engineering systems, both sides learning from each other, this is how we do big, hard things. And this is just a beautiful example, she added. According to the U.S. Department of Energy, scientists have successfully produced a nuclear fusion reaction that produces more energy than it uses. This innovation may move humanity one step closer to having an endless supply of renewable energy, thereby discarding the environmental crisis. But how quickly will that plan be attained? A so-called net energy gain is a significant step in the decades-long quest to harness nuclear fusion, the reaction that occurs when two or more atoms are fused. The experiment supplied the target with 2.05 megajoules of energy and produced 3.15 megajoules of fusion energy in return, producing more than 50% more energy than was supplied. It is the first time an experiment has significantly increased energy. This monumental scientific breakthrough is a milestone for the future of clean energy, said Democratic U.S. Senator Alex Padilla of California. The nuclear fusion reaction has produced the first overall increase in energy in human history. It is a critical step on the way to clean energy, even though more research, a lot more research, is required to make the technology repeatable, scalable, and more effective. Well, let's dive more profound into what exactly nuclear fusion is. Atoms are fused to form a single giant atom in nuclear fusion. The process is the primary reaction that powers our sun and produces vast amounts of energy. Nuclear fission, the method utilized in nuclear power plants, is distinct from nuclear fusion. Instead of joining atoms, fission divides them, producing hazardous, radioactive waste. Rather than relying on radioactive materials buried in the earth, nuclear fusion is far more efficient, generates minimal waste, and runs on hydrogen atoms readily available in seawater than relying on radioactive materials buried in the earth. It would be the perfect choice for powering anything from homes to factories if it could be scaled up. Since the advent of fusion, a century ago, researchers have been working feverishly to comprehend and simulate the mechanisms in a lab. However, performing a fusion reaction known as ignition, which takes less energy input than it produces, has eluded scientists. A group of scientists from the Lawrence Livermore National Laboratory's National Ignition Facility made its breakthrough in California on December 5. On Tuesday, Energy Secretary Jennifer Granholm referred to this breakthrough as a milestone. The thermonuclear inertial fusion process was used in the nuclear energy breakthrough in December, which occurred at the National Ignition Facility. 192 lasers from the $3.5 billion laser complex are fired at a tiny capsule. 2 hydrogen isotopes in the capsule, when bombarded with energy, instantly vaporized. Resultantly, vast amounts of energy are released during the fusion process. The energy input from the lasers in the past was far greater than the energy output from the fusion process. On December 5, though, scientists made a fresh attempt. Minor faults have a less significant impact on the experiment, since the capsule they utilized had a thicker shell than in other studies. Something extraordinary was made possible by this straightforward and remarkably reproducible modification. At the press briefing on Tuesday, Dr. Marvin Adams, NNSA Deputy Administrator for Defense Programs, explained the procedure. He stated that the procedure started with a small capsule, about half the diameter of a BB. 192 laser beams entered from the 2 ends of the cylinder, he said, and struck the inner wall. X-rays from the wall impinged on the spherical capsule. Fusion fuel in the capsule got squeezed, and fusion reactions started. This had all happened 100 times before. But last week, for the first time, they designed this experiment so that the fusion fuel stayed hot enough, dense enough, and round enough for long enough that it ignited, and it produced more energy than the lasers had deposited. About 2 megajoules in, about 3 megajoules out, a gain of 1.5. In terms of energy, a gain of 1.5 seems insignificant, and it is. A reaction occurring at all is more important than its size. The nuclear fusion breakthrough on December 5 resulted from a century's worth of study, funding, and failures. Fusion as an energy source was little more than a science fiction gimmick before this milestone. Even if there are still many steps between now and practical viability, today it's a reality. Is nuclear fusion the future of clean energy? Nuclear fusion is promising, with many companies making excellent progress. Here are some to consider. 1. 35 countries collaborated to develop ITER, the first fusion reactor in the world to produce net energy. ITER is scheduled to start up in 2025. 2. Commonwealth Fusion, commonly known as CFS, is developing the SPARC fusion machine. The company was founded in 2018 and anticipates starting operations in 2025. 3. General Fusion is generating commercially viable fusion energy. Between 2022 and 2025, the company intends to construct its prototype facility. These three businesses should be investigated because they are the industry leaders, and in a few years, we may be able to attribute our home's energy use to them. Reproducibility and affordable reproducibility will be some of the following technological milestones that must be obtained for nuclear fusion to be something that meaningfully powers our electrical grid, which is a crucial perspective here. As a result, a reaction like this can only be performed at this plant occasionally, and it produces, for instance, just approximately 3 megajoules of energy. Therefore, that may be equivalent to boiling 10 kettles of water by burning 1 kindling log. It's not a lot then. This type of reaction should occur about 10 times every second for this to be practical at this time to provide a usable amount of electrical power. Many experts are telling this. Therefore, the main issue is that they need to increase the net energy gain for each reaction. And to do that, they must increase the efficiency of their lasers. The other possible scenario is that the process stays the same. Still, they find a way to do it repeatedly, closely spaced apart, and significantly less expensively than currently. To achieve the highest nuclear fusion energies documented, facilities are currently operating in Europe. They are therefore working to increase their profits, but they have yet to attain the net benefit that we can see from this American federal lab, because it can potentially be a clean and almost unlimited energy source. Nuclear fusion is immensely alluring to investors and academics. Nuclear fusion doesn't produce long-lived radioactive waste. Nuclear fission, which now generates roughly 10% of the world's energy, produces these materials, which must subsequently be disposed of safely and ethically. Helium is the only substance you obtain from it that you do not require, and helium is an inert gas safe for all living things. Additionally, it doesn't produce greenhouse gases like carbon dioxide, so it doesn't have the same impact as burning fossil fuels. Additionally, burning fossil fuels use more energy than nuclear fusion. That's the underlying reason why there have been so many investments in this particular field. So, commercial fusion companies have received more than $5 billion in investment in recent years, but not all are working on the same kind of fusion reactor design. Most funding goes to facilities that use fusion, which occurs in a device enclosed by strong magnets. In other words, it's not the same kind of facility as the American lab that recently announced this. I think approximately $180 million has been raised by companies following the laser-based strategy. The main allure of this technology lies in its capacity to produce sustainable energy. However, practical nuclear fusion energy is still very likely years away, if not a decade or more. It won't be a panacea at this particular time because the world is warming by measurable degrees over months to years. Governments and commercial companies could benefit from investing in this field in the long run. So, what do you guys think about this video? Please share your reviews about what you think about the future of nuclear fusion as clean, limitless energy. I hope you liked this video. If you get it, remember to like, share, and subscribe. Stay tuned as we will come up with many more new and more informative videos.